All right, welcome everybody. So my name's Kyle Boon. I think that the description of this talk said that I work for SmartThings, which was true when I told Kevin that I would do this about 3 or 4 weeks ago. But now I work for Target, so I've been here for 2.5 weeks. But at least right now, my team isn't using Ratpack. So this talk is based on work that I've done at my previous job at SmartThings, which is just across the river. And also, I have a little side project called Cellar HQ. So this is like a website for people who collect beer. And basically, it's an Excel spreadsheet that knows about 40,000 beers that you can put in here. We wrote this in Ratpack about 3 years ago, well before it was in 1.0, and it's been running in production ever since then. So I have a lot of experience running. This is not a huge app. I think it gets about 10,000 uniques a week. But it was the biggest Ratpack app for a long time. And it's also all open source. So if you ever wonder what a big Ratpack app might look like, this is one that you could go look at. I still, when I can't remember how to do something, this is usually the first place I go look. So it's on GitHub, and if you ever want to help add stuff, I have not touched it in a year because I have a baby now, and I don't have time for fun projects. Okay, so also I have a series of blog posts called Zero to Ratpack that I've been writing for, I guess, the last 2+ years, and this talk is really just based on those blog posts. The blog posts are all in Groovy, and all the code today is going to be in Java. So if you ever want to look at stuff, there is a lot of, there's actually a lot more in the blog post than I think I'll have time to cover today. So I think it's a pretty good resource. And I actually didn't have to change too much of the code from older versions of Ratpack to make this talk. So. Also, this is sort of a new format for me. I've never done a talk where I do mostly live coding and have no slides. So I'm interested if people think it's OK. And any feedback you might have, find me afterwards. So the title of the talk is Modern Web Development on the JVM with Ratpack. And so I want to start by talking about what is modern web development, which is obviously a very subjective idea. And so I'm going to give you sort of a list of things that I value. And then I'm going to talk about how Ratpack sort of fulfills those needs for me. So first of all, what I'm talking about is doing like web-based API development, and that's what Ratpack is sort of meant for, obviously, HTTP-based services. Focus on testability, having a very short feedback loop, something that starts up very fast, which is also related to having a very short feedback loop, and implements a lot of the sort of requirements for a 12-factor app. If you haven't heard of a 12-factor app, it was a sort of a pattern developed by Heroku, and basically, if you follow all of the sort of tenets of the 12-factor app prescribes, then your app should be relatively easy to deploy into a cloud-based environment. And that was something that weighed heavily on the development of Ratpack. Another thing that is important to me is sort of being designed for modern languages, and so Ratpack is on the JVM, and it was designed from the ground up to run on Java 8. They decided very early that they were not going to support Java 7 or Java 6 or anything older than Java 8. Of course, Java 9 is supposed to be released at the end of July, I think, so I guess I can only claim that that is a modern feature for a few more months if they actually hit it. I Googled it, and they said July 27th. That's the latest date I've seen. So I sort of cheated a little bit. I mean, a lot of this stuff is you can just sort of read that as a goal of Ratpack right here on their homepage. But I think that these things you'll also find these features in a lot of sort of modern JavaScript web frameworks, and as well as things like Spring Boot or Dropwizard, which accomplish a lot of the same goals as Ratpack. But at least for Spring Boot and Dropwizard, they don't do it in a reactive way, and Ratpack is reactive from the ground up, which is sort of the main thing. So it's a lot easier to actually get into what Ratpack is. It's a lot easier to talk about what Ratpack isn't, because it's not very similar to a lot of other frameworks or APIs that you may have used, at least that are based on the JVM, because it's not based on the MVC pattern. It is not a full stack environment like Spring Boot or Grails is. It's not convention over configuration, which has been sort of the go-to style for, ever since Ruby on Rails came out, 12, 15, I don't know how long. It's been out for quite a long time now. And it's not an implementation of the servlet specification. So it's built on top of Netty, and it's asynchronous from the ground up. Almost all of the methods you'll see in the Ratpack API will return a promise. And so everything from reading the body of a request to getting a cookie that's all based on promises, it's asynchronous from the very, very core levels of the framework, which is something that other frameworks, if they try to provide asynchronous features, usually have to bolt on, and it's just not native to them like it is with Ratpack. Ratpack is basically a series of libraries, and you can compose them using any build tool that you want. The creator of Ratpack, Luke Daly, works for Gradle, and so most examples you will see with Ratpack are going to use Gradle, but you can absolutely use Maven if you wanted. I don't know why you would, but you could. And you can use it very easily from IntelliJ. It's very discoverable from an IDE. It's all strongly typed, and you can click through to any method and read a lot of very descriptive Java docs, basically. And we'll see that kind of later on. So that is all of the sort of just talking I'm going to do, and we're going to get sort of right into coding. So I have sort of like 7 different segments in this talk. And I'm going to try to hold off for questions until the end of each one, because I'm afraid that if I get stuck in the middle of one, I'm going to totally forget where I am. So we're just going to start by doing Gradle init. This is just going to create a basic project structure for us. It just built. Is that pretty visible in the back of the room? Good. So it basically just started our build.gradle file. It added the Gradle wrapper, and it started. Thought it was going to have a source directory in there for us, but that's OK. So we'll start with a source. And I'm going to jump right into IntelliJ. One too far. And we'll jump into presentation mode so you guys can all see this. If worst comes to worst, I have all this code in Git with tagged, and if I get like super lost, I can just jump over and copy it out later. So one nice thing about Gradle that I like is that you can basically write a Gradle file like from memory, which I definitely cannot do with all the XML that's in Maven. I have to look at my notes just to remember the names of the plugins I need to grab. But the actual, so this is the latest version of Ratpack. Oh, I don't know why it didn't create. Never mind. I was going to use a feature of Gradle that you can actually give it a, and I have it here in my notes. But basically, you can give it a set of like a base type, and you can say create a Java application. The way I did it just created an empty application. But so we're going to start by creating our first class, which is going to have sort of our hello world version of Ratpack. If we were using Groovy for this, we can make this short enough that it would fit in a tweet. But since Java is still Java, you know, I love Java, but it is a bit verbose. So this is sort of where we're going to start here, and this is basically the entry point to the application, and we'll come back to this class over and over again throughout the entire presentation. And we're going to start by giving Ratpack a list of handlers and a chain that builds that list of handlers, and we will talk about what those do in a second here. All right, and if I did not make any typos. That? You know, it sounds so easy to do this, and like I wrote this code like 3 times in the last few days, and then as soon as you get in front of people, it's like so nerve-wracking to type. And it's like what we do all day, every day, and it's still very nerve-wracking to type. There we go. All right. All right. Ratpack has now started. I don't know if people can see that. It says hello, Skyway. That's it. All right. So a little bit of typing. That is sort of the very basic, simplest possible Ratpack application. And I'm going to get more into what this is actually doing in just a second. Let's build an actual reverse proxy now. So a reverse proxy, right, is like Nginx. It's going to take a request in and then forward that request to another service on the back end. This is a really sort of fun pattern that you can do in Ratpack, easier than you can do this in a lot of other frameworks. A lot of frameworks I feel like have sort of a canonical example of like an easy thing to build. Like when Ruby on Rails came out, it was like build a blog in 5 minutes, and then when people started doing WebSockets, there was a lot of like real basic chat apps. And I think that a great canonical example of an app to build in Ratpack is a reverse proxy. So we're going to start mostly with what we have here. And instead of calling get, we're going to call all. And I think actually, well, I'll just go ahead. So we need an HTTP client because we're going to make a request from here to another web service. Exactly. So what the all method does is tell Ratpack every single request, call this closure or lambda, regardless of the path. Every single request is going to get called here. And the one that I used before, the get, and we didn't specify a path, that only called for the root URL. So, and we need a URI that we're going to call. So the original URI is going to be the URI that we were called with. And I'm going to, so the context is an object that's passed to every single handler. And you can sort of think of that as dependency injection inside of your handlers. So it holds the request and the response, and I'm gonna sort of do some hand waving stuff about how we're getting this HTTP client out of the context. We'll talk about that a little bit later. But basically, the context is gonna be in every single handler, and you can use that to get things you need out of it and to change how the Ratpack app is going to respond to things. So there's a request on the context, and then that has a raw URI on it. And then we are going to proxy that URI to another one. And this is also, I think there's probably libraries I could use to grab to make this a little bit shorter, but I have to actually build this up from the original one. I've imported the wrong one. We're going to find a specific host and port that we want to go to. We'll do that in a second. And then we're going to use the original path that was passed into us. And we're going to use any query parameters. And we're going to define this. We're just going to hard code this. And we're just going to hit localhost. I have another app running in the background already. It is also a Ratpack app. We can look at the code later if people are interested. It is an implementation of a very basic to-do API. So we're going to hit that. That's going to be our proxy URI. So anything that comes in, we're just going to proxy it to the exact same URI to a different application running already. Now here's where we're going to talk about sort of the asynchronous nature of Ratpack. So this is going to like a short example, but it actually touches on all of the main sort of things you need to know about to build a Ratpack app. So in order to read, let's see, I'm going to build this up a little bit slower. We're going to make a call to the HTTP client. Let's see, so, and we're going to stream that request. To the proxy URI. Did I import the wrong one? Damn it. There we go. Thank you. This is like, what do they call this? Mob programming? 60 people working on the same thing. We will get it done eventually, right? And then we're going to give this thing. There's lots of lambdas in Ratpack apps, and there's lots of passing in lambdas that configure something. And so in this case, we're giving it a little lambda that's going to configure the request that this HTTP client is going to make. And what we're going to do is we're going to copy the headers, because we want this app to be, this request to the backend application to be as similar as possible to the one that we're sending. And this, again, is going to take a little function, and we are going to copy the headers from our sorry, so we've copied the headers over, and we're also going to copy over the method that we're using. So now if we do a GET request, we're going to do a GET request to the backend service. If we do a PUT request, we're going to do a PUT request to the backend service, et cetera. So what this is returning is a promise for a streamed response. So we have to tell Ratpack that once we have that streamed response done, we're going to do something with it. And it's going to pass us a streamed response. And we are going to forward the streamed response to our current response. Does that make sense? So basically, the response we get from our backend service, we're going to send to the original requester of this. And if everyone has helped me get through this, yes. All right. It looks kind of JavaScript-y, someone said earlier when they were looking. But we can refactor this and make it a little bit cleaner later on. I'm not used to presentation mode, and I don't know how to. I guess I gotta go here. We have started a lot of processes. All right. Now we're running again. Sorry. So I have, this is the other application that's running. So I called, this application is running on port 5050. This other application is running on port 5151. And we can actually see that it logged, that it got a request and sent to 200. And we can see that this one here, it's just, there's nothing in there, so return an empty list. We can do a post. Oh, that's wrong. And this is going to fail. And I'm going to tell you why here in a second. It's going to HTTP. It's better than curl because there's less to type. Okay, so let me jump. So does anyone know what we are missing? Correct, right? We didn't pass in the body. I didn't want to jump right into that because it sort of nested promises, so I wanted people to sort of see the earlier one, and then in Ratpack, like I mentioned earlier, you have to reading the body is returns a promise. It's an asynchronous operation because the body could be very, very large, and so you want to do it not on the main request processing thread. So in order to do that, we're going to get the request, and then we're going to get the body, and this returns a promise. And we're going to flat map that. So if people are familiar with promises, the Ratpack promise API is very similar to other promise libraries you would have used. It's also very similar to RxJava, and if you want to use RxJava, you can use that with Ratpack very easily. So flat map is going to turn one promise into another promise. keeping all of these nested things straight is a bear. Okay, so, and then what we're going to do is we're going to move the then. So what we're doing is we're going to actually, we have to actually copy the body over. And that we do with, let's see, there's a method on here. And we're going to get somewhere I'm missing another one of these. Oh, yeah, we do. I'm too used to Groovy and not having to do things like that. All right, so now we're returning a promise to the flat mapper operation. And then once that one has been returned, that is now the type that returns a stream response, and we can forward it over. So now if we restart our app, that post should work. And now we can send a post, and you can see that in this other application, we submitted the post. So this is, I mean, basically a fully functional reverse proxy. It's a little gross because we have everything in a single class, in a single file, and there's a lot of stuff we can clean up about this, but it is a fully functioning reverse proxy, and it's actually super, super fast. We did things like this at SmartThings all the time. We would have little microservices that would add headers or remove things to go from external traffic to internal traffic. It was a super common pattern for us. So the things we've talked about in here are the chain, which we saw way up here. The chain is a thing that builds handlers and composes them together. And handlers, you can think of handler as a function that either sends a response to an HTTP request, or it does some work and then delegates to another handler. We also saw the promise API, which, if you're familiar with promises, is very similar to other things. And we saw the context, which a context is basically a registry, and it lets you to get things in a handler. It's a mostly correct way to explain it, but it's good enough for what we're doing here. Are there any questions about this? It was sort of a lot, and a lot of people telling me that where I was missing semicolons. Yeah?
So if you have to get some data and save somewhere, I'm not very familiar with lambdas. How do you do it?
So
with lambdas, usually, so the question is, with lambdas, a common problem is it works well. You try to save data somewhere, and then, how do I do it? So
in terms of doing persistence, it's sort of the last step in my demos today. So we'll get to it. That's the answer. But you can totally do it. But basically, there's a special type of way to do blocking operations in Ratpack. Any other questions? So this took much longer than I was thinking to get through the first sort of example. I doubt we'll get through the 6 others that I have. So I may actually start to cheat a little bit and jump into sort of some finished examples so that we can walk through it without the painful semicolon missing. Which, yeah, I think I'll just go ahead and do that because there's a lot of interesting stuff to look at, and I don't want. Yeah, question all the way in the back.
Are there any good libraries that you've used for persistence layer mapping, maybe in RDBMS databases that work well with Ratpack?
I totally did not understand you, sorry.
Are there any good libraries that work well with Ratpack if you have a persistence labor, like MySQL or Postgres or something?
Yeah, you can use mostly anything you want. Ratpack is very, very unopinionated, and it will let you use any persistence layer you want. The one that I'm going to talk about later is Juke. and sort of my new favorite way to do SQL-based persistence, at least. Thanks for the question, Aaron. And so, all right, so as I was mentioning earlier, I sort of have all of this done, luckily. And I'm going to look at my tags and remember which one is which. All right. So the second part of the sort of demo is basically doing configuration. Because in our app, we had just sort of, I don't know why I didn't, sorry. Here we go. Originally in our app, we just had some static configuration that said the host was going to be localhost and the port that we were going to forward to is 5151. That's not very fun. So we wanted to show how Ratpack does configuration because like we were talking about with the 12-factor app, this is one of the sort of the core tenets of Ratpack, which is really easy configuration that's easy to override for various environments through environment variables and system properties. So how we're going to do that is we're going to have a server config block, and then we're going to, there's a shorthand for this later that I'll show, but basically we're going to pass a properties file named application.properties, and then we're also going to say that we're going to accept environment variables and system properties that are given a specific name format. And we'll show that also in a second. And this is showing that we want to require a section of our configuration to be a proxy config. And then we're going to load that configuration from this file into an instance of this class. And this class is just a host, a scheme, and a port. So after this is executed, this thing will be loaded. And then down here in our handler chain, we can replace that configuration. We can get the instance of the configuration out of the context, the same way we did with the HTTP client and the request and other things. So we're doing that using the class type. And then once we have that, then we can just replace where we used our hard-coded values with the proxy config values. Otherwise, the rest of this handler is exactly the same. And then the next example is testing, and that is going to show you how we actually used this configuration. Actually, I will show just the application properties file real fast. So just like any properties file, nothing very interesting. I just put the same stuff we had configured, localhost, HTTP, and 5151. All right, I remember that I forgot to tag one thing, which is okay. It's still in there. It's just part of part 5. So this is, wanted to show how easy it is to test in Ratpack. So I wanted to write a test for our awesome reverse proxy. And here it is. So I know that I said this was mostly going to be a Java talk, but this is Groovy and this is Spock. Because I don't know the last time I tried to write like a JUnit test. I assume that's what people still use if they were going to try to write tests in only Java. But I refuse to punish myself. So the tests are in Spock. It should be fairly easy to follow along with. And if you haven't seen it and you're not using it, you definitely should be. So here's our Spock spec. And there's a couple of key things to point out here. Is that we're going to start an application under test. And we're going to pass in the name of our class in order to do that. So when this test starts, it's going to actually start a fully running Ratpack application in the background that can accept requests. And then we have a test HTTP client, which is automatically configured to be able to make requests against that application. We're going to ignore this proxied host here for just a second. And then because we don't want to have an external service running for our tests, I don't want to have that little to-do app running in the background every time I want to run my test suite. I want to set the configuration to something that I can test against every single time. And that's where this proxy host comes in. So what this is a very tiny, I think this would fit in a tweet. I didn't count, but it looks like it would fit in a tweet. It's a very tiny Ratpack app that is just going to render some text. It's going to tell you what raw URI was hit, no matter what path you send it. And we're going to use that to test that our application, our reverse proxy, can hit multiple different paths. So here's the actual test, and all we're going to say is we're going to get the text of URL and validate that it's going to be rendered, and then the URI that we're sending it. And so in this case, we're testing the base URL, an API path, and an about path. And I'll just run this to prove to you that it works. Oh. I'm not going to do that. I know why I'm jumping around to a lot of different places, and IntelliJ is not keeping up with me as much as I would like it to, but that's okay. So basically, this test will just start up an application, configure the actual application to proxy to this little tiny application that we wrote inside of our test. I actually have a blog post about this. I've used this in many other frameworks like Grails and Spring Boot, where I wanted to test hitting an actual third-party service inside of a test, like a functional style test. And you can use this without needing to have a Ratpack app as like your actual application. So you can just import this as a test library. It's very, very useful. So this is basically a functional test, right? Because we're starting an application, we actually have real configuration, we're actually hitting a third-party service in the background. So this is a functional test. Because I'm not running it right now, but this took 1.7 seconds to execute when I ran it yesterday. So it's a functional test, but it runs very fast. And I find myself way more often than I would with another framework using functional style tests because it's fast enough that I don't really notice it that much. There are lots and lots of test fixtures for doing unit tests in Ratpack. Anything that you want to unit test, you can. But I find myself really sticking to unit tests for things that are just purely business logic. And if anytime I'm going to test something that is using part of Ratpack core, I'm going to use a functional test for it. Basically testing my handlers and configuration and things like that, I'll use a functional test. Any questions about tests? Awesome. Next section is about rendering HTML. So we talked earlier about Ratpack really being awesome for doing API development and doing basically rendering JSON and things like that and writing microservices. Did I get turned off? Okay, oh, sorry. Of course, the very first thing that I wrote is like an enormous, very conventional web app that renders tons and tons of HTML and doesn't really have much of an API to speak of. I probably wouldn't do that again in Ratpack because there's not as many niceties as you're going to get in something like Grails. I could probably write Seller HQ in Grails in a third of the code. And because it doesn't really get that much traffic, it doesn't really need to be as fast as it is in Ratpack. But I did it back then because Ratpack was brand new and I wanted to learn it and I thought it was fun, and it was. And I learned a lot, and now here I am doing this. But if you're going to do a conventional web app, I'd probably stick with something else. But even most microservices that I work with will end up using something in rendering HTML at some point, and I want to show that you can definitely do that with Ratpack. So I think we're on part 6 now. There's sort of 2 parts in here. Okay, so in this tag, there are 2 different things. One is refactoring to modules to make our code a lot more understandable and more modular, and the other part was doing the HTML. So I'll kind of just talk about both things at the same time. All Ratpack functionality is distributed in modules. Modules is really a term from Juice, and it's sort of co-opted also in Ratpack. So in this, we're using Handlebars to render HTML. And so Handlebars has a module that's distributed with Ratpack, and it just provides a bunch of simple fixtures around loading your templates and rendering them and passing models into them. So this Handlebars module is a Ratpack module that comes with core. I just added it in Gradle by using this right here. It's pretty simple. And then this is the actual Handlebars application, or the Handlebars page. So all we're doing here is adding like a little admin page that's going to show what the configuration is like. And then we had to add another handler to handle a /admin application. So that's this handler right here, where we pass an admin path to it, and then we're passing, in this case, we're actually passing a config handler. And this is that class. So all this handler does is get the configuration out of the context, and then using the context to render a Handlebars template. And we give it the name of the template, and then we have to give it a model, and the model is what's available. So here it's giving a config object, and that config object is the instance of proxy config. And then we can see in our Handlebars file here that we're using this model to display. And just to and here's what that page looks like. Very simple. One thing that I want to point out is that order is very important in a Ratpack handler chain. So I want to show what happens if I was to put this second. Or last, I guess. So if I try to refresh this page, 404. Why is that? It's because the way handlers work is that it's going to step through all of these handlers, and one of them is going to return a response. And the first one that does that wins. So in this case, this proxy module, the proxy handler, which is exactly what we wrote that took longer than we were expecting, it's exactly the same thing. That wins because it grabs every single request, sends it to the back end no matter what, and then returns a response. And the to-do app doesn't have an admin path. It only has a to-do path. So it returned to 404, and now our application returned to 404. This is probably one of the more frustrating things in a Ratpack application, because if you get this wrong, it can result in a day of trying to figure out which handler, if you have a big application, which handler is stealing your request and why. Especially actually if you're using Groovy, there's a really nice DSL for building these handler chains, and it gets rid of a bunch of the, it gets rid of all of the problems that I had with semicolons and parentheses earlier. But sometimes that DSL can be a little bit, you're not doing what you think you're doing, and then you'll actually not be responding to the request the right way. That's actually a lot harder to do with Java, but you can still have handlers that aren't doing what you think or out of order. So we can put that back. Again with the parentheses. So to talk about the modules, so there's another, I added 2 other modules, right? One is an admin module and one's a proxy module. All these are really doing right now is providing handlers. So like in my Seller HQ application, I have like 4 or 5 different modules, and that a lot of times what you'll do is you'll take your application and you'll break it up into bits of functionality, and each one of those bits of functionality can go into a module. And what's really nice about that is if you ever decide that you want to turn that into a whole separate application, you can basically just remove it from one application, import the module into another application, and it's ready to go. It's fully contained. So this module, all it's doing is binding an instance of config handler into the registry, which makes it available to our context. This is using Juice to do that. I want to show there's a couple different ways you could do that. So bind, abstract module is a Juice module, there's a Juice class. Bind is a method as part of abstract module. Configure gets called automatically by the application when it starts up, and then once this is called, it's going to call new on a config handler, which doesn't do a whole lot. There's no nothing in there, right? And then it'll add that to the context. The proxy module, I did a little bit differently. There's nothing in the config handler, and there's a static method that builds up a new instance of a proxy handler. And then down here, I actually just said, I added the proxy, the handler in this way. There's no real difference in these two other than stylistic differences. And if you don't want to use Juice for some reason, and so a lot of times you'll see like this right here, and I'll show you what this does. This request logger, this is a handler that's part of Ratpack core, and it uses this exact same pattern. And I wanted to show it just because you'll see a lot of Ratpack code, particularly from core, that uses that pattern to provide handlers. And what this does is it provides the request logger that we see down here at the bottom. And this is my favorite feature of Ratpack because I added it. It's the only thing I ever added into Ratpack. And I bet that my name is nowhere in there anymore because Luke, who runs, he's very opinionated on what code should look like. So he merged my PR and then he basically rewrote the whole thing. But I do have a commit. So I just like to show that off. But basically, this is doing the same thing. It's just a static method that returns a handler. All right, so that is making our app modular. And we are on to the last section, database access. How are we doing on time? All right. Actually, this is the final version of all the code, so I may as well just work off master now. So there's a couple, so this is using what Aaron asked about earlier, which is Juke for database access. And I'm not going to talk a lot about Juke because there's only a few minutes left in the presentation. And basically, it's just a way to do SQL access in Java. It's very different than like Hibernate. In my opinion, it's cooler. I'm going to show a couple different things. Juke does a lot of code generation for you, and so we're just using an H2 in-memory database here, and there's this Gradle task which is going to connect to that to this H2 database, and then generate a bunch of code for us. I've already done that. All that code is in here. So what we're going to do here is we're going to add a way to sort of blacklist certain clients from connecting to our reverse proxy. So if Mike has written something that is abusing his privileges with our application and we want to block his IP address, you could use this feature to do so in a very naive way. So we have a blacklist class. This is all generated code. You would never need to look at any of this. But basically, it lets you do SQL in a type-safe way that will actually compile and tell you if you have written an incorrect SQL statement. And then it makes it pretty easy here. So that is just sort of high-level stuff. And then I want to show the configuration. So there's a Juke module, which I wrote for this. Doesn't do a whole lot. It is going to provide access to the base Juke object, which is a DSL context, and it's using a data source to do that. And then the DSL context is what other services or other classes can use to make database queries. And then this one also is going to provide a repository pattern. So this is using Juice to provide these to the context for us to use in our handlers later on. So it's going to provide a blacklist repository where we can add and remove stuff. There we go. That should be a little bit better. There's a couple different things that we do in here. So this one is a fetch all. It's just going to get a list. This is the Juke. This basically builds up a SQL query that's a select star from a table. And then this is sort of the important Ratpack bits. So basically, this is saying that we're going to do a blocking request, and this is going to return a promise to us. So anything that's inside of the Lambda that we pass to this get method here is going to happen on a separate compute thread. And then that's where you can do database access, and you're going to block waiting on the response from your SQL database. A lot of times people will think about database access or file access being sort of the main blocking things you might do in a web application, but it's really anything that's going to take more than a few nanoseconds. So when we first released Seller HQ to great fanfare, it was actually an application that we took over from someone else, and it was a Grails application. And it was in pretty bad shape, and so we decided to rewrite it from the ground up and using Ratpack. And so we did that, and then we took everyone's data. It was using an Amazon, I can't remember their NoSQL database. I think it's Sunset. But anyway, we exported all the data out of that, and we put it into an Amazon RDS database. And when we did that, we basically had to reset everyone's passwords because we didn't want to export them and then re-import them for various reasons, right? So what we did was we sent everyone a link and said, go reset your password. And when you clicked on that link, it would take you to a page and would let you reset your password. And we were using bcrypt to encrypt people's passwords. And we wanted to be very secure, so we had picked a value in bcrypt that would give a very, very secure hash of your password. And it turned out that that was taking like 200 milliseconds to encrypt this password. And we were not doing that on a blocking thread. So basically, once one person started to reset their password, nothing else could happen on that server, on that thread, for 200 milliseconds. Not that it gets a lot of traffic, but a lot of people got blocked that day, and then the whole server was just down because only 5 people could hit it every second. And so I learned very quickly that blocking operations are not just for database access. They're also for encrypting 250 cell, if you're going to do that. We backed it way down and found something that just took like 15 or 20 milliseconds, but it was still happening on a blocking thread. In Ratpack, anything that's going to take more than a very, very short amount of time should be done on a blocking thread. So that's what we're doing here. This fetch into will actually do the SQL query, and then it'll build a list of this class for us. And so what this is returning is a promise of a list of these models. And then we have a similar thing for adding, where we take a model in. This is the Juke part where we're going to basically, this builds up something that it knows how. This is like an active record type pattern that Juke provides. And then we're doing a blocking operation. We're going to store that record. And then after that returns, we do it called next, right? Which is sort of like then. Basically, we're going to refresh that record and put it back into that model, and that means we'll have the ID available. questions on sort of the basics of database access. So we can look at how this actually gets used inside the handler. So here's the handler. So basically this is a little teeny tiny REST API where we can do two things. We can get a list of blacklists and we can add things to it. We're not bothering with delete or update because there's just an in-memory database and we can just restart our application. So that's the only two things that are available. And we can run this guy. This is what I was showing earlier when, so first we'll do a get, there's nothing in there. And then we will, we added a post. And we're putting in the non-canonical IPv6 version of my localhost IP address. And then, so there's one more part. What are we actually going to do with this blacklist to prevent people, bad people like Mike, from accessing our awesome to-do API? Actually, this was. So the proxy module has a new handler in it called restrict host handler. And our app has added that before the proxy handler. So this is what this thing looks like right now, right? So the first one is to admin blacklist, and then the HTML get endpoint, and then restrict host handler, and then the proxy handler. So the order is super important again. And this is what it does. So we take our context in. We're going to get our blacklist repository out of the context, right? And then we're going to get the host that made the current request that we're dealing with. Then we're going to see if there is a host that has been blacklisted in our database. And then, so this is returning, this find by host is returning an optional because they may or may not be blacklisted. I can't remember the name of that for some reason. All right, so if that blacklisted host is present in our blacklist, then we're going to do two things. We're going to get the response, we're going to set a status, and we're going to send the text blacklisted so they know they're bad. And if there is no blacklist present for that IP address, we're going to call context.next. This is a really important feature. This is basically how you chain together functionality. So if you do this, that proxy handler that was defined at the very end of the chain will never get called unless you call context.next. So in this case, we render a response, we don't call it, and in the other case, we're going to actually call the next handler. And then we can do a quick demo to prove this works. I'm tired of searching through my history here. Blacklisted. Sorry, Mike. This is sort of the end of the demos. Any questions about the database stuff or anything else that we've talked about? Mike, you got to wait for the microphone. Pause.
So you've given some examples of how what you've used Ratpack for, and you gave the one example of Seller HQ as being something, if you were to do it differently, you wouldn't create the monolith kind of approach that you did there. Are there other types of applications or services that you would say you would recommend not using Ratpack for?
Yeah, I mean, I think the sweet spot is anything that needs to be very responsive. I think anything that is sort of like, I mean, most of what I'm doing in my work these days is, REST-based microservices that do JSON, and that is perfect sweet spot for Ratpack. Also, anything where you want to, if you're writing a microservice that is going to collect responses from other microservices and collate them and then return like a single response, something like, kind of like an API gateway or something like that, right? You're going to collect responses and return a bigger result. That's also a really great use case for Ratpack. And then I would say don't use Ratpack for other stuff. You're not going to use it for writing a giant HTML-based app. There's not great response right now for doing like WebSocket type stuff. I think that they want to add more support for that. I know people who are using it for consuming Kafka messages and things like that. I don't love using Ratpack for that, but I also don't really have another way that I love doing that, like to build up a little teeny tiny service that all it does is grab a message off a queue and then maybe write a message to a different queue or something like that. So I would, if I had a better alternative, I would say don't use Ratpack for that either, but it's sort of as good as anything else right now. Like at least I don't know of anything that is like a framework that's just based on doing that. And Ratpack does give you a lot of niceties around the configuration and things like that, so it does provide some value there. But there's talk of in Ratpack 2 sort of taking a bunch of the HTTP specific stuff out of, not out of, but making it a little bit more modular so that you could actually do that a lot more natively. Right now you could use Netty to do something like that and just go straight to Netty to consume messages from Kafka or something like that, but you're not going to get any of the higher level constructs that you get from Ratpack. Other questions? No. All right, one more question.
Do you know of any great resources for like learning about Ratpack?
Oh gosh, a leading question from Mike. The question is, are there great resources? There are so many great resources. There is a book, and I'm trying to, here it is. The book was written by Dan Woods. He's local now. And it actually is a very good book. Sorry, what? Dan Woods does work for Target now also. But the best part about this is that I endorsed this book. And let me tell you, Dan worked on this book for like a year and a half. I worked on this endorsement for like 15 minutes. But I still get to see my name on the book. And I think I'm making the same amount of money as Dan is too. Actually, Dan's awesome, and all the proceeds from the book are going to Great Ladies, which is a community for encouraging minorities, women, and other minorities in the Groovy community. So it's a great book, and the money goes to a great cause if you decide to buy it. And Dan should have come. He could have got a clap. That would have been great for Dan. He loves applause for himself. And then Craig Burke is the other person but there's a reason I'm above Craig. Craig speaks at GreatConf, which happens in July here in the Twin Cities. There will be a lot of Ratpack talks at GreatConf, I'm sure, this year. And it's a great conference. If you're looking for more Ratpack information, you should go there. There's usually a lot of the core team. There's, I think, 3, including Dan, there's 3 core team members that live in the Twin Cities. So there's a lot of people here doing Ratpack development. The other good resources are the Ratpack documentation. The Java doc is actually it's pretty good compared to most things, compared to most Java docs. So a lot of the Java docs have these code samples in them, and I've never seen any other project do this. These code samples actually compile as part of their build. So anytime their examples break because they've changed code, their build breaks. So these code samples are always up to date. So this is 90% of what I go to when I'm trying to figure out how something works in Ratpack. There's a Slack group. Slack group is great. And I think there's still a forum, but I don't think anyone, after the Slack group started, I don't think people really use the forum anymore. And I think, you had a question?
So with regards to all the examples of why you said we should be using Ratpack for, can you, in your professional opinion, I guess, sell it over like something like Spring Boot, which is a very popular Java framework?
So one of the advantages of being synchronous from the ground up is you're going to use a lot fewer threads. Threads are, Spring Boot still is a thread per request. Threads are very, very expensive in Java. There's like a separate stack created right for every single thread. So a lot of times I think the default is like 512K for a stack size. And so every thread you create is going to have 512K reserved for the stack. And so you can change that, but I think that's the default. So if you have to process several thousand concurrent requests, you're using a lot of memory just for that. And at least right now in most cloud environments, memory is way more expensive than compute resources. So most of the time you'll be at 10% CPU, but you got 8 gigs of heap space, and so you're paying for that. In fact, I run Celery HQ in Heroku, and even there I have a hard time like staying cheap and using I use none of my compute resources, but all the memory they give me, at least during what passes for high utilization for Celery HQ, but it's just over the edge of starts to actually cost me money. So I think that's a big advantage, especially also if you're doing things where you want to do concurrent requests to other systems, and you want to do that all asynchronously. Then I think anytime you're going to start down the async rabbit hole, you may as well just go all the way in instead of because you can use an asynchronous HTTP client, Retrofit can do it, other things can do it, right? And you can use that inside Spring Boot, but you're still going to be using a thread per request, and why not just go all the way and be async all the way, up and down the whole stack? That said, depending on who's on your team, there may be a bit more of a learning curve there. Not everyone is used to working this way. At SmartThings, we had some stuff that was in Spring Boot, some stuff that was in Grails, some stuff that was in Ratpack, some stuff that was in DropWizard. And there is a very high mental price for switching back and forth between doing async stuff and doing regular synchronous stuff. And so someone will be like, hey, can I ask you a question about these promises? It's sure, I'll read that in an hour and a half. I will remember how it works and tell you an answer. And so when you're switching back and forth, that you can definitely pay a high price there. But I think it just what fits your eye. I like Ratpack. I like the way the code's laid out. It looks pretty to me. I like it. And it's sort of just a happy-feely thing, right? Some people love Spring. Spring is great. It does a lot of things for you, but sometimes the magic gets annoying to me. There's no magic in Ratpack. Everything's right there in the main method, and you can click through and read the Java docs. There's no annotations that you have to try to figure out what collector and processor is doing stuff with them, and I like that. But you can build, successful projects with either one. Other questions?
How does it stand up to Node.js, which is also a non-blocking?
That's a hard question to answer. So Ratpack is not in the, what's the name of the, where they measure 1,000 different frameworks. Why can't I think of the name of it right now? Is that what I'm talking about? No. They measure the response time. They have a set test, and they measure the response time for a bunch of different things. No one knows what I'm talking about? Gosh, I should have put this in my notes. Basically, they're not in there. There's a bunch of like Express, I think, is in there. Netty is very, very, very fast. It's at the top of the list all the time. So is Vertex, which is, I think, also, it has a bunch of similar characteristics. I think that you will find at least comparable performance. But Node.js is like a really big topic, right? So you have to compare it to a much more specific framework inside of that. I know John Colviner's in here somewhere, and he was asking about Koa and Express. And Koa, I don't know that much about JavaScript, but because John asked in the notes in the online invite for this talk, I looked at Koa a little bit, and it has some similar there. And so I think you'll probably find similar performance characteristics. But I think in general, Java's faster than JavaScript.